If you drive through the rolling green plains of northeastern Wyoming, you eventually hit an anomaly, a colossal monolith of rock stretching over 1,200 feet into the sky, sitting entirely alone in an otherwise flat landscape. Look closely at its shape. It has a perfectly level, sheared-off plateau at the summit, and its sides are lined with rigid, vertical columns bundled together like a fistful of giant cables. It looks incredibly deliberate. This highly irregular shape has fueled a persistent internet theory that this monolith is actually the petrified stump of an ancient, miles-high tree. The idea gains traction because this exact geometric pattern repeats all over the world. Take a look at the Giant's Causeway in Ireland, where tens of thousands of similar interlocking columns spill right into the sea. From a distance, these formations bear a striking resemblance to the cross-section of a sawn log. The vertical pillars bundle together exactly like the cellular tissue and thick outer bark of a colossal redwood. Our brains are highly tuned biological pattern recognition machines. When we see grouped vertical lines capped with a flat plane, our intuition immediately screams tree stump, because biology is the only place we usually encounter this kind of regular, organized geometry. But random wind and water erosion don't carve perfect 30-meter-tall hexagons into stone. The mathematical uniformity we are looking at requires a specific engine to build it. If we completely rule out a lost world of giant flora, we have to ask what kind of blind physical force can engineer such an exact, repeating geometric structure out of solid rock. To find the answer, we have to put aside our familiar biological instincts and look at the intense thermal dynamics of a much younger, much more violent Earth. What we are actually looking at is a geological process called columnar jointing. It is the physical footprint left behind when massive underground pockets of molten magma eventually freeze into igneous rock. When superheated lava sits in a thick pool, it begins to cool, and as the rock cools, it shrinks. This contraction builds up an enormous amount of tensile stress across the entire deposit. To release that intense stress, the top layer of the rock fractures. Initially, these surface fractures are completely chaotic, forming random T-junctions that look exactly like the dried, cracked mud you see in a drought. But as the cooling front moves deeper into the lava pool, something remarkable happens. The random cracks slowly reorganize themselves. They seek the most efficient, lowest energy way to relieve the tension, naturally annealing into a tight, repeating grid of perfect hexagons. Because the heat is escaping evenly straight up to the surface, those hexagonal fractures are pulled directly downward through the depth of the rock. The flat surface grid extrudes deep into the earth, slicing the solidifying magma into distinct, parallel pillars. When softer rock surrounding these pockets eventually erodes away millions of years later, tightly packed, multi-sided stone columns are exposed to the open air. The precision here isn't the product of cellular growth. It is the rigid mathematical signature of extreme heat permanently escaping a confined space. Physicists can actually predict the size and shape of these columns using a metric called the Peclet number, which calculates the exact relationship between the speed of the cooling front and the material's thermal properties. Because this is a universal law of thermodynamics, you can perfectly replicate the structure of Devil's Tower in your own kitchen. If you take a thick layer of wet cornstarch and dry it with a heat lamp, the escaping moisture creates the exact same physical stress. The only difference is scale. The exact same mechanical laws are shaping 1 mm cornstarch columns and a 1,200-foot mountain of basalt. We can also compare these geometric towers to actual, verified petrified forests, like the one buried in the Gallatin Range of Montana. True petrification happens when an organic tree is abruptly buried in a flood of volcanic ash. Over thousands of years, mineral-rich groundwater slowly circulates through the wood, molecule by molecule, replacing the living cellular structure with solid silica. This chemical swap preserves the highly irregular, chaotic shape of the original organism, complete with uneven growth rings and tapering branches. It never produces mathematically identical, uniform pillars 30 meters wide. Earth science gives us two completely distinct realities running in parallel. Biology can turn to solid rock through chemical replacement, while pure, lifeless magma can perfectly mimic the exact structure of a living organism simply by cooling down. Because columnar jointing is driven by universal physics rather than local biology, We don't just find these structures on Earth. High-resolution orbital cameras have mapped massive, unmistakable clusters of these exact same hexagonal rock fractures stretching across the Marte Vallis region on the surface of Mars. The giant tree theory is incredibly alluring because it takes the massive, indifferent forces of our universe and scales them down into something safe, biological, and easy for humans to understand. Clinging to that biological illusion keeps us from recognizing the truth that the universe is governed by an underlying raw mathematical geometry that organizes matter without any need for living cells. So, the next time you see a photograph of a flat-topped, perfectly columnar mountain, try to look past the optical illusion of the giant stump. Think instead about an ancient Earth violently churning with oceans of liquid fire, tearing itself open and flooding the surface with superheated rock. It was the strict, unyielding laws of physics that brought that chaos to a halt, carving mathematically perfect towers out of the cooling magma. Realizing that blind thermal mechanics can spontaneously construct such immense, precise geometry is far more compelling than any myth.